Golf. It's a sport that requires a high level of skill and perhaps a small portion of luck. What stands out in this sport is the humble, oddly shaped golf ball. However, the dimpled shape promotes specific flight characteristics which defied aerodynamic theories from the great mathematician Jean d'Alembert. Besides helping the sport, the golf ball has also helped understand aerodynamics on a molecular level. One important factor of the aerodynamics of a golf ball is the boundary layer. A boundary layer is created when an object travels through a medium, such as air. Air molecules in front of the object will stick to the surface. These molecules will then collide with oncoming molecules, and this causes a resistance to motion, and this is known as drag. For a smooth object, such as a sphere, the boundary layer is laminar, which means it is layered. However, due to the air friction, there will be a separation point where the airflow will no longer flow along the sphere's surface. This results in an area of low pressure behind the object, and therefore produces a suction. This goes against Jean d'Alembert's theories that a sphere has no drag. He did not consider the effect of air resistance, and it is this that defines how far a sphere may travel through a medium, such as air. For a golf ball, the boundary layer is turbulent. This means that air molecules are unable to stick to the surface. This results in less drag, as less molecules are colliding with oncoming air molecules. Thus, the separation point between the airflow and the ball is much later compared to the sphere. This means there's a smaller area of low pressure behind the ball. Evidence for all this can be shown from Reynolds' number. It analyzes fluid dynamics and helps to characterize laminar and turbulent flow. It is represented by the ratio of inertia force and viscous force. This takes into account the force of the golf ball and the force of the air resistance. It depends on the shape, speed of the object, and air density. The higher the number, the more turbulent the air is around a golf ball, which will allow the golf ball to travel even further. Aerodynamics is not just involved with the drag of an object, but lift as well. This is possible if the golf ball has backspin. Then it will warp the airflow, which will result in a higher pressure towards the bottom of the ball, thus causing lift. In the end, the dimple golf ball does not only maximize range, it also allows upward lift. This is why there are golf balls that have many different amounts of dimples. Each has its own flight characteristics to match the need of the golfer.